Hi, everybody. Welcome to Demo, the show where companies come in and they show us their latest products and platforms. Today, I'm joined by Christian Posta. He is a VP and Global Field CTO at Solo.io. Welcome to the show, Christian.
Thank you, Keith, for having me. Excited to be here.
Yeah, Solo.io is the name of the company, right? It's because you wouldn't just say Solo, would you?
Some people do. I've been here one of the longest, and it's about 6.5 years. I say Solo.io.
All right, so tell us about the company, and then tell us what you're going to show us on Demo today.
Yeah, so what we work on is application layer cloud networking that translates into things like modern API gateways and service mesh. I think with all of the hype and now realities around AI and AI agents that we're working with our customers, a lot of that happens on the network, and there are some big differences in the way we talk to APIs versus how agents interact and talk with AI models. And now we're digging headfirst into that with our customers, and we have a handful of open source projects that we've brought to the community that solve agentic communication pattern.
Okay, so within the enterprise, who is this mainly designed for? You mentioned the word network. I'm assuming some of the network guys in the enterprise space, or is it more of a developer kind of connecting tool?
Definitely network, definitely security.
Yep.
Primary consumer so far has been platform engineering teams, and now AI platform teams.
All right, and so what's the big problem that you're solving for these companies? Why would someone be interested in watching this demo, basically?
Yeah, so whenever you put something on the network, you need it to be secure. You need those interactions to be observable. You probably have compliance and governance procedures that need to be adhered to. And especially in the world of AI, where things are not as deterministic as they are in the microservice and API world, you need to be able to put guardrails and boundaries around what these systems are able to do. And if you look at the emerging protocols in the AI space, the AI inferencing space, things like Model Context Protocol, MCP, or agent to agent, or A to A, those don't solve for security, observability, and guardrails. So that's where we come into the picture to bring AI agentic architectures to the enterprise and fill in those gaps, because those protocols probably won't do that.
Right. So if a company did not have something like what you're going to show, would they just be introducing new potential vulnerabilities as they develop more agentic AI, or is it something else? Yeah, it would just be
No, that's a big concern.
Yeah,
I think a lot of people are the leaders are saying, hey, do AI. But they're also like, oh, wait a minute, this introduces a lot of new security vulnerabilities that we don't really understand yet. So, we need help.
All right, so let's get into the demo and show us what you got.
Right. Okay. So the first thing I'll do is I'll start off with a kind of a high-level architecture of what what an agentic architecture might look like, where you're building agents yourself. You might be bringing some in off the shelf, like copilots or coding agents. We have an open source project called K-Agent that allows you to build agents very quickly on top of Kubernetes. But the important bit here is those agents communicate with AI models or LLMs. They communicate with other agents, and they communicate with back-end APIs or tools, as they're called. And in those protocols, like MCP or A to A, like I mentioned, they don't natively solve or bring security to the table. So when you start giving an agent who is supposed to be this autonomous system to go off and achieve goals and tasks for you, and give it access to APIs and workflows inside your enterprise, you want authentication. You want very fine-grained authorizations. You want to be able to audit, what is the path that this agent took. And as these things are communicating over the network, what we've done at Solo is we built a new open source project called Agent Gateway. And this Agent Gateway understands MCP protocol and the A to A protocol.
Okay.
And because it does, it can enforce security and metrics collection and tracing and that kind of stuff. So the demo that I'm going to show here is about the Agent Gateway. Actually, if we go to GitHub Agent Gateway and look at the Agent Gateway project here, This project is built in Rust. It's very important for performance and resource usage reasons to have it built in a system language like Rust. The proxy is configured with a JSON file. It can also be configured with an XDS type protocol, but I won't show that right now. So with a JSON file, we can specify a single endpoint that clients can connect to and then reach a number of back-end MCP servers, each which expose their own tools. And now you can apply governance and policy and so forth on top of that. The Agent Gateway has a UI. So in this case, we can see the listeners that are exposed here, the target MCP servers in the background, and a way to interact with those to test things. So if I want to connect up, I can see what are the tools available on this Agent Gateway. In this case, you can see we see the everything echo and then everything else add, and so we got a list of tools here. Now that's great to be able to see it, but what if you have APIs in the background? What if you have RESTful APIs and you want to expose them over a MCP protocol? So to do that, why don't we take a look at OpenAPI, and we'll run the proxy as a OpenAPI. And if we look at the config for that just real quick, we can see we're proxying now not just an MCP server, but we're proxying a OpenAPI REST service as well. All right, so if I come back here and refresh and take a look at our targets, we can see the pet store backend is a RESTful API, but we're exposing it to MCP clients, which then make it available in an agent or an LLM. If we connect to the playground again, we can see the available tools are those everything server tools and the pet store tools, right? And now if I call it using MCP, I can get the Agent Gateway to do that transformation between MCP and REST automatically. The last thing I'll show is authentication and authorization and policies that we can write around MCP. So if we come back here and take a look at that JSON file real quick and auth, what we see is, we expose one endpoint. We are going to expect JOT token to be included with the request on HTTP. And we'll say that, yeah, you can access this, but you can only access the Echo tool, not everything on the server here.
Okay.
And so if I come in here and come back to the playground here, and I connect up, select the endpoint, and click connect, we're going to see that we can't actually connect because we don't have the token here. So let's go find the right token here. I think that would be, oops, no, not there. Right here, hopefully in the README. All right, we got a token here. And we'll pass that into the field here. We should be able to connect, cross fingers. All right, that looks good, connected. Now, remember the policy that I showed says we can only call the Echo service. So if I try to call, I don't know, add the add tool, if I go 1 + 2 = what? Nothing, because I'm not allowed to call that.
Right.
But if I click on the Echo service and I say, hello Agent Gateway, I should be able to run that, and it does. It completes successfully. Now, the Agent Gateway, like I said, is one piece to this agentic puzzle, and it can enforce security, observability, guardrails on communication from the agents to the LLMs, from the agents to other agents, and for the agents to the back-end MCP tools that we just showed right now. All of this also needs some sort of governance, so we include a registration portal for approval, workflows, and so on, for what agents are allowed to be exposed and tools and so on. So this is what we're calling Agent Mesh, and Solo, I feel like, is leading the cloud native community for sure on building these types of tools.
So with a lot of this, when you're adding all of these agent gateways, is that going to add any additional time for a lot of these transactions to happen with the agents, or is it still relatively quick for a company to add this without adding additional time for a lot of these calls?
So that's a good question. That's the primary reason why we built the Agent Gateway in Rust. Rust is an extremely performant and resource conscious type programming language. But at the end of the day, you should think about agents as smart workflow engines, right? Workflows, they take steps, they take interaction, they take feedback and so on, and try to figure out a particular response and goal or end goal. They're not as, it's not a high frequency trading system. This is not a, nanoseconds type API response, but nevertheless, we built it in Rust because we do feel like that does need to be performant in these environments.
Okay, and how can people get more information about this? Or, is there a free trial offered, or can they just go in and basically play with it on their own?
The tools are open source. The ones I mentioned, K-Agent, that is open source. We've donated that to the CNCF. K-Gateway, which I didn't mention, but is the umbrella project for the gateway tools, that's CNCF. Agent Gateway, open source project, potentially donate to the CNCF. We'll see. Those are a number of open source projects. Okay. Go to solo.io, our website, to work with us or partner with us on some of this stuff. But go check it out.
All right, very cool. Christian Posta, again, thanks again for being on the show, and thanks for the demo.
Thank you, Keith.
That's going to do it for this week's episode of Demo. Be sure to like the video, subscribe to the channel, add any thoughts you have below. Join us every week for new episodes of Demo. I'm Keith Shaw. Thanks for watching.